And ladies and gentlemen, welcome to OpenStack and Cisco ACI. This is a vBrownbag session that will give you information and demo about OpenStack running on top of the ACI managed fabric, which is actually also called Application-Centric Infrastructure. My name is Ifti, Rathore, and I'm the technical marketing engineer for OpenStack on ACI. I'll start with just a little foundation for ACI. The ACI is a combination of Cisco's hardware, which are called Cisco 9000 switches, and then on top of that is actually a management controller, which we call APIC. Together, it actually makes the ACI ecosystem, but these switches can also be used as standalone switches, which are the Cisco 9000 switches. We also have Cisco 3000 switches from the same business unit that actually use a merchant silicon and actually give you a very low latency switch. So the Nexus 3000 switches have a merchant silicon, and Nexus 9000 switches can have a combination of merchant silicon or the Cisco's cloud scale technology, which is our latest innovation. It's industry's first 50 gig and 100 gig switches. You actually get 50 gig switch, a 40 gig switch for a price of 10 gig and 100 gig switch for a price of 40 gig, which means if you invest in 10 gig technology and 40 gig technology at this time, you're actually future-proofing yourself. It uses the cloud scale technology, which is the Cisco's own silicon. It has full telemetry analytics. It does wire rate net flow, so the full visibility can be actually in your network and your operation. And we have also open choice for the SD and network automation. I will actually get into a little more detail of that. So what is ACI? ACI is a simplification or an abstraction on top of the network and application APIs. So it actually tries to abstract things so that the underlying infrastructure is actually knowledge of the underlying mechanisms is not necessary to manage and operate these fabrics. It's actually the heart of this is the ACI controller, and it actually controls all the switches. And when we actually bring ACI into the picture, it takes over the whole fabric, and it's a fully managed underlay and overlay fabric, which actually has an API on top of it. And you have a central way of actually provisioning and enforcing all your policies and managing your fabric. And we have a lot of toolkits and infrastructure pieces that you can use to actually automate your infrastructure. As to talk about the abstraction is required because the application developers and the language of the application is very different from the language of the network. So network language is VLANs, network, subnets, firewalls, default routes, and static routes, and ACLs. Instead of that, application people say, well, I want these applications. I don't want these applications to be talking to each other. I want to protect my app tier from actually having access from outside. I want my web tier to have access from the outside. And how we're going to put what is my tenants. I want multi-tenancy. That they talk in those languages. So this is actually a way of bridging the gap between these technologies. We also provide full visibility because the underlay and overlay are both managed by Cisco or Cisco ACI, which means we can actually have full visibility of anything that is virtual or real. We can have visibility into that. For example, we can chase instead of chasing our virtual endpoints and trying to figure out where they are and where their traffic goes, we have full visibility. We can actually look at a virtual endpoint, and we can actually look at all the traffic that is going to it, what policies it is using, what traffic is generating, and we can also generate events on top of it. Centralized management and open API, yes, it's all REST-based, so we can cook our own way of automating and managing, or we can also use the standard off-the-shelf mainstream OSS, BSS tools to manage it. And the third thing is health scores. We actually have, it provides us a very good way of actually looking into how the health of an application, not just a full data center, each and every application, which we actually categorize as endpoint groups. So how is my endpoint group doing? Are there any packet loss? Are there any problems? All that is managed. I will show you the demo very soon. So these are some numbers about the ROI for some of our customers that are actually had achieved the ROI by actually using the ACI and Cisco 9000. So now let's go to the beef, where actually the real the story is. What can we do for OpenStack? So when we're using ACI, we provide an OpenStack plugin that actually gives us two different ways of managing our applications. But I will get to that in the next slides. But the OpFlex for OVS is basically a policy manager that can actually get all the policies from ACI and implement them locally. Which means all the policies actually get implemented or pushed down to the hypervisor, and the features that you get is fully distributed. All Neutron functions are fully distributed on the compute nodes, centrally managed underlay and overlay, and full visibility into the OpenStack operation, all the Linux hypervisors, and also their data paths and through the APIC. And another thing that we have is choice of two different ways of deploying applications on OpenStack. One is the traditional Neutron API, which we actually call modular layer 2 plugin. This is a confusion because both plugins are modular layer 2, but one uses the Neutron API and the other uses an API called GroupBased Policy. The GroupBased Policy gives us a way of actually deploying our applications without having to worry about a network-centric view. So we do not talk about subnets, we do not talk about networks or anything. We just talk about applications, and we talk about how they will behave and how they will interact with other applications, which we call group, hence the group-based policy. Since everybody here understands Neutron API very well, Neutron API, when we use, it's very much looks like any other Neutron application. We create Neutron networks, and we create routers, we map gateway exactly the same way. Group-based policy is different, so I'm going to go into more detail. The underlying infrastructure, how ACI sees the virtual systems and how the visibility gets, is exactly the same if we're using ML2 or a group-based policy. So group-based policy is 100% OpenStack, open source. It's actually Apache licensed. It is made for basically capturing the application intent, which means instead of going down into the details of how it is implemented and what networks will be used and what firewalls or policies will be used, we abstract it to groups, which are basically kind of like L2 domains. And then the policies between them that are kind of L3, or maybe it's just a rough way of saying that routers in the middle control that actually these two subnets can talk to each other. In this same case, in ACI, there are no routers. What we have are contracts, which allows the traffic to be allowed or denied between two entities, two endpoint groups. So it's slightly different, but it's abstracted well so that you do not have to understand the internals of the networking. And right now, we're only applying this to the networking subsystem. So when we actually say, I want this group, it's actually mostly talking about the networking properties of this group. Like it can talk to the internet on port 80 and this can talk to the database on using database port. But it's actually going to be added to more and more subsystems like storage and compute to be also policy driven. And we have a lot of new vendors coming in, and we're expanding this ecosystem. And more acceptance is coming in. Group-based policy model is basically a set of actions which could be allow in case it's a white-based model, so it could have allow, implicit deny, which means you have to allow everything that we want to allow. For example, we say if it's a web traffic, if it's SSL, allow it. We can also say if it is SSL, redirect it to an SSL concentrator. So we can have others too, copy, which means if you want to actually span it or you want to monitor it. But for now, I'm just only going to cover the allow. So allow means this action is allowed. And then what we have is the classifier. Classifier tells us what is the classification of that type of traffic or thing that we're trying to allow. Would be TCP, ICMP, UDP, port 223, or TCP port 80. These are the classifiers, and what we take the classifier and we add it to the action. We say allow this, which becomes a rule. We take allow TCP, allow ICMP, we combine them together, becomes a rule set, and that rule set is the what actually we attach to the group. We say, well, web can consume the rule set for the external access, which means people can get DB. Web can also consume the DB access, which means it should be able to talk to the database or the app tier. So that's how we actually do that. So, and then we have like basically the layer 2 policies and layer 3 policies. We also have interaction with external world. So what we have is if we're actually taking two groups, web and database, we can say that these can talk to each other, and can they also talk to this? So how these groups interact with each other and also interact with the external world is governed by the group-based policy model. To creating a policy, as I already mentioned, that we create the rule sets, and then rule sets actually are created in 3 different steps, as I mentioned, and actually I will show that in a demo. And then we create the external networking groups, and then we take the groups and we say these groups are going to consume these policies, and then we say we want members. I want to have 3 members in my web group. I want to have 4 members in my database group. It will be like spawning virtual machines, creating instances, and attaching to those networks, but having the right policies and everything automatically done without having to worry about the network. When we actually install, use group-based policy, there's another menu that is added to dashboard, which is called the policy menu. So all this can also be done through the policy menu, and also it adds a heat module, which means we can also use heat templates to manage and create and deploy these policies. So the scaling and everything is in there. Another thing I should mention is the group-based policy also have API for automatic API for service insertion. So if you're using group-based policy, it becomes much easier to do service chaining and insertion. So it's ACI and OpenStack. This is true for group-based policy or neutron model, that all the functions are distributed on the hypervisors, which means there's no central new node, and all the routing is done actually by ACI directly from the compute node. Integrated underlay and overlay, it's fully managed. That's why we get actually the full visibility. If we actually have a third-party overlay, then it becomes a little problem of chasing all the tunnels that are going, because it's all basically virtualized. Hardware accelerated performance, it does VXLAN in hardware, so we can actually get line rate performance without having to waste too much CPU cycles. Service chaining, ACI actually has a very good way of service chaining. There's also something that we call device package that allows you to bring firewalls and other service layer 4 to 7 services into the ecosystem to be used as policy. And it's very easy to actually bring it even if we're using Neutron API, for example, load balancer as a service. It's very easy to actually bring a traffic from a load balancer into a load balancer from any subnet or any EPG, as we call, any network which is in the virtual. We can have full visibility into them too. We get full operation and telemetry. We'll actually have a small demo to show that. And secure multi-tenancy means since we actually own the underlay, we control the underlay. Even if somebody gets into the overlay and hacks into one of the hypervisor, it's still very difficult for them to actually go, and actually go through the underlay. Our partners, we have many more coming. These are 4 partners current. We actually fully integrate with them, fully automated install. So if you select ACI plugin, when you're installing this, it will automatically install and configure the plugin for you, the fully automated. And these organizations test and certify our plugin, and we actually co-develop with them. And so in some cases, for example, Mirantis and SUSE, you will actually get everything from them. In case of Red Hat, we're working with them, so it will become basically if you use any of these vendors, you will not have to do any extra steps to use ACI. This is a customer SunGuard. Their availability services. They actually have, they're a service provider that actually provide networks and application platforms to their customers, and they're actually using the group-based policy, and they have a very good set of services that they're actually offering to the customer, including bring your own network, and so VPN as a service, and a lot of different services. Because they're using the group-based policy, the services are actually much easier to do. Logical network topology is very similar to all other OpenStack topologies, except that the virtual machine traffic or overlay traffic goes through the ACI, because the ACI actually manages the overlay. All the tunneling is done managed by ACI. Other traffics, for example, storage traffic or private traffic or API traffic or external will always go through ACI, because that's the benefit of actually using ACI, because it'll do the full line speed routing and distribute it for you. But like if you want to have management traffic also go through ACI, we can also do that. So any traffic can also be routed through ACI, not just the VM traffic, because it is a switching and routing infrastructure. It provides the external access. We have the external network that already configured, and you can use basically Neutron to create the provider network, and then everybody else can use it. But that will also use this external network. We see that the Neutron server has the plugin, which could be in a group-based policy mode, or the Neutron ML2 APIC mode, which is actually just using the Neutron API to create network instead of group-based policy to deploy applications. All the compute nodes have the DHCP server, the L3, the NAT, the floating IPs, the metadata service is local to each and every hypervisor, which means practically there is no Neutron node. There's only one server that has the Neutron process running and the plugin installed. But besides that, everything else is on the compute node. It's actually very easy to configure those compute nodes, because they really just only talk to the ACI, and then there's a process that talks to the Neutron that I will actually get into in a second. And the traffic between the VM traffic that I was talking is between the compute node and the top of the rack switch, that is the ACI, can be VXLAN or VLAN. Internally between ACI, all traffic is VXLAN, but depending on what the requirements are, if you want really high scalability and line rate, and you don't want to burn too much CPU, you can keep that as VLAN. Or you can keep it as a VXLAN and use a VXLAN offload network card to get the scalability. But you have all the choice. You can actually make it before or during the implementation or during the operations. The architecture is very simple. We have on the compute nodes, on the controller, we already mentioned that we have basically the plugin running and the Neutron server. But on the compute node, we have the Neutron agent that actually talks to Neutron, gets the endpoint info. After that, we have the OVS agent that actually talks to ACI and gets all the policies for these endpoint groups. And then it implements them locally on the Open vSwitch. So all the policies, as we say, there's no router. It's a contract, and the contract is just a policy. So those policies come down from the ACI, And that's how Open vSwitch would actually know if it will allow this traffic to happen or not, or will it drop it, or will it NAT it. It's all because the policy that it's getting from the ACI. And endpoint file is local to every host, and it's actually it's a file system based, which stays persistent unless we lose the compute node. So this was the just a simple tour through the plugin. Now I'm actually going to switch to the demonstration. I will first go through the the group-based policy demo. So for this, escape. Yeah, there it is. I'm sorry, there was some lag into getting the video up. Now it is up, so let's. I'm going to start it. So we have 2 compute nodes installed, and one controller that I'm actually logged into. We have group-based policy, and as we see, there's the policy menu. Everything becomes available. Everything is deployed and configured through the policy menu. We do not go into the networks. We do not go into the tenant instances. We do not go to any other menu to do that. The first thing we do is we're going to create some action. So the allow is the action that we're creating. When that is done, I'm going to start creating my classifiers. So for example, the first one I'm doing is my database class, which is what policies database is going to provide, and then which is actually TCP and ICMP. For my web group, I'm also going to use TCP and ICMP, but I'm creating 2 different TCP groups for them because we can control the port. So that's why I'm actually keeping these different. So now we created the ICMP classifier. Once the classifiers are created, I am actually going to go and create the rules, which means we combine the classifier with the action, what could be allow or redirect or any other actions, but right now we're only doing allow. So I'm going to add the TCP class, TCP rule, and then we created the DB rule, which means we have now 3 rules. Now we can actually take these rules and we can combine them into a rule set. So first I can create is the database access, which is going to be the database rule and the ICMP. ICMP I'm keeping an all because what we do is we use ping to demonstrate this. And for the other policy, which is my external policy, that's TCP and ICMP both. Now I'm going to go ahead and create the groups. One is a web group and the other is the database group. So these are the groups that we were talking about for implementing group-based policy. I'm actually in the beginning, I'm not going to go ahead and give them the consume and provide relationship so that it's much more clear. Then we configure the external connectivity. External connectivity is because we already have an external network, which I'm calling DC out. We're going to tell it to use that DC out as the external policy. And we gave it basically the external route and everything. This is, of course, done by a network. This is the only time we deal with a network. After that, when the application guys are deploying, they will never have to worry about the network. And then we actually go ahead, and since what I want is internal to my web servers, I want external access, I want to give them floating IP. So this is what we're creating. We're creating the floating IP pool. Then now I'm going to create a group that will provide that particular the policy, and then the The web group is the one that is going to consume this policy, and then you will see that it actually automatically will. So we created that, and we told it to use the DC out. Now I actually go ahead and I'm going to create the service policy. This policy will actually have everything that need that. Okay, what we need is to create this IP pool, which is the NAT pool, and use the data center out for this. Well, I'm going to go ahead and update my L3 policy to use that data center out that we have created. So now this external access is completed. Now we can actually go back and work on our groups. So what I'm going to do is go ahead, edit those groups, and say that a database is going to provide the database access, which means anybody can connect. Anybody who's going to consume it can actually connect to that. And then for web, it's going to use the DP. It's going to consume the DP access and the external root set, which means it can talk to the database server. It can also talk to external world, and external world can talk to it. Now creating the members, which means I'm just going to go ahead and create the two members in database group. I'm going to create 2 members in the web group. So as we say, this is similar to spawning or instances, but I see I'm never going to mention any network details. It automatically picks the network details for us. And if we have the floating IPs required in that particular policy, it will automatically give them floating IP. As we see that we have 2 web servers, they already have the floating IPs, the internal IPs. The database is on 192.168.1, the web is on 192.168.0. We never mentioned it, so which means it automatically picks these things depending on how we configure the policies. And now we see the database can actually, web server can actually go to the external network, which means it can go to the internet, and it can also get to the database tier. And now we can also see that external world can also come to the web. So all the policies that we actually configure are working correctly. So and this is how we actually, so somebody who's going to deploy these only would create the groups and how they're actually consuming different policies and providing different policies and start creating the members. Internally, as we see, is it actually is going to create the endpoint groups for those applications, as we see, and we can actually see that it has discovered those virtual machines that are in that endpoint groups. It's providing us all the information, even what VXLAN tunnel they are on, what MAC address, what is the port on the Linux. We can even get that what is actually the port name on the hypervisor that it's attaching to. So all that information is here, and also the policies we can see that are all in here. The provider and consumer relationship is there. The VRFs are also created exactly the way we want. So it's actually completely does everything for us and pushes the policies up to the ACI, and everything is actually done in the ACI. So now I'm actually going to go to the next one that is going to show you the so troubleshooting and operations. We have 2 networks that we have created. One is net 100 and the other is net 200. Between these, we're going to spawn the virtual machine, which are already there, and then we're going to ping one to other, and then we're going to create a fault. And then after that, I will show you how actually we can trace that fault. Sorry, sometime it's the buttons don't respond, but that's okay. So we are going to start a ping from one the network 200 VM1 to the network 100, which means we're actually going across the fabric. We're also going across a subnet, which means we're actually going from one network to other. And we can, the first thing I will show you that we can actually go ahead and see this, this traffic by looking at the statistics. And this is also showing you that 100 health score means everything is fine, there are no problems detected. According to as the ACI sees these two endpoint groups and the traffic between them, there are no issues, there are no packet losses. We can also do collection, statistic collection, so we're actually setting up the collection here. And it shows us whatever we configure, we can actually hit the checkbox sign, and we can add more collections or remove. We can also do it through external OSS and BSS system, but this is just to show you. And we can also see that what the networks that we have created and the virtual machines that we have actually are detected on those particular networks, which are actually the endpoint groups in this case. And we can also collect statistics per that endpoint. You can see those MAC addresses for the two virtual machines, and we can actually start collection for these two virtual machines or one virtual machines. So which means we can actually do statistics per endpoint, even though it does not matter if it's virtual. Now what we're going to do is create an interruption, which is one of the interface that is connected to the fabric. We're going to bring it down. What that will cause, it will cause the interruption in the ping that we were seeing. And as that happens, we will also see that the APIC has detected that, and it's going to say that the health score for that particular application is not good, right? So which means it shows the 50 mean there's something wrong, like the health score is 50%. We can actually go to the health, and then we can follow this fault chain to find out exactly where the problem was. In this case, it's showing us that it's actually on the port ETH1/34, the port that we brought down. So we can actually use this to find the root cause of the problem. We can go and fix that issue and restore the connectivity or whatever the issue there was. So as we see that, we have that. And I'll just quickly go through another operations one before we run out of time. So this is the advanced troubleshooting. So this is very similar to the last example. I already have the network and the same two hypervisors, but we already have networks created, and I already have virtual machines running on it. So we have these two networks. One is 100 and one is .200. It is actually connected to a router, and then we have two of these instances running. And then what I will do is I will actually go and I'm going to go into the operations of the APIC, and I will show you that we can actually look at these endpoints. So first what I'm going to do is I'm going to start a ping between those two so that we can actually, most of these operations may not require you to have live traffic. They can generate their own traffic between endpoint groups, but some of these do need those. And the same as we saw in the last one, that we actually can see all these endpoints. Now what I'm going to do is I'm going to put these two endpoints, two virtual machine IPs in my in APIC, and it actually shows me where exactly they are and how they're connected. So it's showing me that they are connected to these endpoints. This is connected to the leaf port. It even shows us the port, and it's going up to the spine and then going to the other leaf switch and going down to the ETH1/7 port. So so it shows us the full visibility. After that, I can say drop statistics. It's going to show me all the drop statistics for this path between these two, which means yellow means that there were drops. So since there were drops, I can actually go and see why I had these drops. Contracts are basically routers, they're much more than a router, but I can actually see policies, what policies are being hit when this traffic is traversing between these two endpoints. And how many were being denied, why they're being denied, and how many are being dropped, how many are being allowed. We can also look at the events that were happening in between these. We can also, most of these can also go to the OSS and BSS system, so we can actually configure those. We can also have a way of doing a trace route between these. So what happens is we can provide a port and a protocol and actually going to do a trace route between them, and then it actually shows us visually by green if it's actually seeing those. So for example, if my traffic between my web and my MySQL is not actually working, I can actually come here and see that if there is actually a problem somewhere between them or is an infrastructure issue. So this allows us to do some more visibility into it. Then we have atomic counters. Atomic counters are for it's actually APIC does transactions between endpoint groups, which means mostly marking packets and sending them, and it measures them and sees if they're actually making it to the other side or not, instead of actually us looking at a lot of traffic going through these wires and then trying to figure out which traffic is mine or not. This actually does it for us, and in the end it just shows us if there are any problems between these two applications. We don't care about all other things or all other tenors that are running on the same wire. It will only show us that these 30 packets were sent and 30 packets made on the other side. This was how much latency there was, and so we can actually, and it will increase as it's actually going. The third more interesting thing that I find is actually the span. I can actually span this traffic at this time from the port, and we're actually very soon bringing it the virtual points. So we can actually span all the traffic that is coming from that endpoint and actually send it to anywhere on the network. In this case, I'm going to send it to a Linux machine that I've already configured as a destination. So it's a pre-configured destination. I'm going to start sniffing on that the VLAN that I am actually sending the traffic to. And then once I start any traffic between those two endpoints, I'll see that it's actually being copied here. So I'm going to start the ICMP, and we do see that it's coming here. So it actually gets encapsulated in GRE and then sent here, and Wireshark knows that this is actually a ER span packet, and it can actually decode it correctly and tell us that this is the ICMP request and reply. So that is most of the demo that I wanted to show you. And so if you guys have any questions, please contact us. We're also in our booth. We're running all these demos, and we're going to answer all your questions. And so thanks for being here.